4. A particle is projected from here with initial velocity u. Now asking the condition required for the particle to describe complete circle. In this case, the condition required is at the highest point the normal reaction should be greater than or equal to 0. Then we have to first find normal reaction. Before that, we have to find the velocity at the highest point. To find the velocity at the highest point, by considering this position and this position to this particle, we apply conservation of mechanical energy. Conservation of mechanical energy. Right. You can then write conservation of mechanical energy applying conservation of mechanical energy. We can write the potential energy zero level is this half mu squared initial kinetic energy minus this height, the radius is 3/2. This height we need, if this is 60, this is also 60, then we get 3/2. Cos 6 is as the height, mg, h is 3/2 cos 60 equals highest point half mu squared plus mg 3/2. We can cancel down m here, and then we get here, by simplifying this, we get v squared, the v squared answer, we get u squared minus 9d/2. We can simplify this, u squared minus 9d/2. Now at the highest point we apply F equals mv downward to find out that r. Now F equals mv, we apply downward. And then we get normal reaction R plus mg is the centripetal force is equal to the acceleration would be v squared by the radius. Then here we can subject R. This is now 2m v squared divided by 3 minus mg. Then we can substitute for this v squared. Then by substituting for this v squared by this answer, and when you simplify this, you get for this r 2m divided by 3 u squared minus 9 e/2 minus mg. Right. So then here we can say for complete circles, r should be greater than or equal to 0. Then we can say that one r is now this part 2m/3 u squared minus 9d/2 minus mg greater than or equal to 0. M you can cancel down. Then you can write u squared minus 9g/2 greater than, brings this side, then g mean time multiplied by 3 and divided by 2, like this we get. Then u squared takes right hand side, we get 3g/2 plus 9g/2. This is u squared coming figure 6g right hand side, u squared greater than or equal to 6g. That's how we take that. Question number 5 next, work and proportion. Now we are given a car moves this way up along an inclined plane. inclination alpha, sine alpha given by 5 by 49. The engine of the car works at the rate 72 kilowatts. So we know the relation power equals tractive force into velocity. By that we can subject the tractive force F, H divided by V. So then here H is the 72 kilowatts. I convert that to watts, 72 into 10 to the power 3. Velocity is 12 divided by 12. Now I found the tractive force. And the weight 2000 G, sine alpha the component, the R is the total resistance. So now we are given the car moves with maximum velocity. When car moves upward on the plane with maximum velocity, you know the resultant force acting on the car should be 0. That means upward on the plane the forces should be equal to down on the plane the forces, right? So then I can write at the maximum height, then we can write 2000 G sine alpha plus R. The forces downward should be equal to that F 72 into 10 to the power 3 divided by 12. Right. By simplifying this, sine alpha 5 by 49, G we are asked to take 9.8, and then when you simplify here 2000, G asking 9.8, and sine alpha 5 by 49 plus R is here 6 into 10 to the power 3. This and this we can cancel down. Then simplifying this, we get R as 4000 newtons. Right. R is the 4000 newtons. Right. But we are given this resistance. The resistance is proportional to its velocity, right? That means R equals Ku. In this case, the velocity is V. Then R equals Ku. R is now 4000. K is the constant to be determined. U is that 12. Then that constant K can be found. 4000 divided by 12 is that constant, right? Now this is the constant K. Now secondly asking, when vehicle works at power 72 kilowatts, find the maximum velocity of the vehicle down the plane. Then the engine is now working at the rate of 72 kilowatts. So then this 72 I convert to watt by multiplying by 10 to the power 3. I took the velocity of the car down on the plane as u. Then according to that, h equals Fe. When you subject F, h upon v, I took the velocity as u. Then the tractive force coming as this. And in this case, the weight, its component down to the plane is 2000 G sine alpha this way. And now, since the velocity is u, the resistance is Ku, or else the resistance is acting in the direction opposite to the motion. So therefore, in this case also, since the car moving with maximum velocity, we are asked to find the maximum velocity. So then this forces acting down on the plane should be equal to the force acting up on the plane. So therefore, we can write that result at the maximum velocity. We can say 2000 G sine alpha plus 72 into 10 to the power 3 divided by u should be equal to k times u. Then substitute for this G 9.8 sine alpha 5 by 49 and k 4000 divided by 12, we get like this. 2000 G is 9.8 and that sine alpha is 4 by 49. 72 into 10 to the power 3 divided by u. K is that 4000 divided by 12 times u. By simplifying this, you get quadratic equation u squared minus 6u minus 216 equals 0. Minus 216 equals 0. Right. Now this is a quadratic equation we get by simplifying this. By solving this, people, you can be to solve this. Once we solve this, we get u18. Then the maximum velocity downward on the plane